All right, so today you're going to work with a fundamental theorem with area and our properties of integrals, kind of a combination of a bunch of things, again, bringing a lot of this stuff together. So back in the last unit, when we talked about the properties of definite integrals, this was one of the properties that we talked about. Integral from a to b of f of x plus or minus g of x dx equals the same thing as the integral from a to b of f of x dx plus or minus integral from a to b of g of x dx. Basically, it's saying that you can take your this definite integral right here and split it up into two different definite integrals. Now, at the time, it didn't seem like, well, why would I want to do that? What was kind of the whole point? Now you're going to see what the point is, because what happens if we have two different ways to evaluate what happens here with f of x and what happens here with g of x? Right? What if one can be evaluated using area and now the other one can be evaluated using the fundamental theorem? So that's why this one becomes an important property. We didn't work with it too much in the last unit, but you're going to see more with it now. So let's take a look at an example here. All right, again, it's kind of a crazy graph. Don't worry so much about, making the graph exact or anything like that. What's going to matter is just that we know what these correct areas are. So if you're going to draw the graph in your notes, just kind of make it like that A is below the x-axis, B is above, C is below, D is above. That's really what's going to matter here. So it tells me that the area of region A is 4, area of region B is 9, area of region C is 3, and the area of region D is 19. All right, now when it gives us that information, what you need to keep in mind is this is just the area, all right? It's not telling us the area with respect to that x-axis. So since area A down here is below the x-axis, even though it says the area is 4, that area is actually a -4. B is above the x-axis. C is back below the x-axis, so that one's going to be a -3. And D is above the x-axis again, so that's 19. So the problem says, find the definite integral from -8 to 0 of f of x plus 2. So what I can do with this, now in the last unit we said, oh, this would be the same thing as a vertical shift. Well, that would be great, except again, these are not nice areas here where you can easily say, oh, I'm taking a rectangle and shifting it up 2, or I'm taking a triangle and shifting it down 3 spaces. In this case here, what happens when I take this area below the x-axis and move it up 2? What's going to happen to my graph on there? So what I can do with this is I can take this and I can separate this into two different definite integrals. I can treat this as the integral from -8 to 0 of f of x dx plus the integral from -8 to 0 of 2 dx. And this part right here is going to go along with my graph. And since I have a graph, the way I can evaluate the definite integral using a graph is by using area. Well, this one over here, 2, is an actual function. So if I have a function, that's where I can use fundamental theorem. So I'm going to evaluate this. Again, I'm separating into two different definite integrals, because in that way I can use two different ways to evaluate what those values are actually going to be. So from -8 to 0, I have area that would go -4. And then I have an area of +9. And then I have an area again of -3. So for this part of my definite integral, -4 plus 9 is 5. 5 minus 3, that one's going to give me 2. This one over here, now I can actually use fundamental theorem. I can take the antiderivative of 2 and I can do f of b minus f of a, because the antiderivative of 2 is a 2x. And now what I can do is substitute 0 in there. So I have 2 times 0. And then substitute -8 in there. So I have 2 times -8. So that's giving me 0 minus a -16, which is 0 plus 16. And that's giving me 16. So from over here, that gave me a definite integral of 2. And over here, that gave me a definite integral of 16. I am adding those two together. So 2 plus 16 is going to give me an answer of 18. So the whole idea is we're using two different methods here. All right, that's why we're separating it, and that's where that property comes in, is when you can separate this into different types of definite integrals. Okay. Let's do one more with the graph here. Okay. Same graph. I'm going to go through and label all that. So again, you don't have to redraw the graph. So you've got, this would be your -4 again. This one here is 9. This is -3. And this one here is 19. So again, what I'm going to do here is I am going to separate this one, right? This time I'm going from -8 to 5 of f of x dx. And then I'm subtracting the definite integral from -8 to 5 of 3 dx. So notice I put this just as a +3, and I'm going to subtract those integrals. So when I broke it up, I treated it as a subtraction on it. So let's start off with our area. You're starting at -8, and you're going over here to +5. So you've got that area of -4, which we already know this first part here. You've got this area of 9. You've got this area of -3. And now you've got this area here of 19. So when I add for this part here, for that first part of my definite integral, I had -4 plus 9 is 5, minus 3 was 2, and 2 plus 19 is going to give me 21. So from -8 over here to +5, this has an area of 21, which is the value now of my definite integral. So now for my second part, here's where fundamental theorem is going to come in. So I'm going to have -8 to 5 of 3 dx. I'm going to take my antiderivative of 3, which is a 3x, and I'm going to evaluate that from -8 to 5, and then use fundamental theorem. 3 times 5 is 15, minus 3 times -8 is a -24, which we could turn into plus 24, and when I add those together, 15 and 24 is going to give me 39. So now I can put these together. My first definite integral was a 21 minus my definite integral here was 39. And 21 minus 39 is going to give me an answer of -18. And there's my value of my definite integral then. Okay. So that's how I can do these with area. So then to finish up, let's do one with a property. All right, same type of idea. Again, this is like ones that you did in the last unit. Okay, so we've got the integral from 0 to 3 of f of x dx is 5. Integral from 3 to 6 of f of x is, oops, left out the dx on there, is -2. Find the integral from 0 to 6 of f of x plus 2 dx. So again, I can take this and I can separate it. I can find out what happens here from 0 to 6. And then I can find out what happens from 0 to 6 of 2 dx. So if I start off over here with this one, integral from 0 to 6, well, of f of x, well, I know what's happening from 0 to 3, and I know what's happening from 3 to 6. So again, this can be one of our other properties. I can take what happens from 0 to 3 of f of x and add on what happens from 3 to 6 of f of x. Because if I add those together from 0 to 3 and 3 to 6, altogether that's going to give me 0 to 6. So that's just the same thing as 5 plus a -2, and that's going to give me 3. Whereas over here, now I can use my fundamental theorem. My antiderivative of 2 is going to be a 2x. I'm going to evaluate it from 0 to 6. So that's going to give me 2 times 6 minus 2 times 0. Well, 2 times 6 is 12 minus 0, and that gives me 12. So now that I've got my answer here for with the properties, that was 3. I'm going to add that on to my answer from my definite integral, my fundamental theorem that I did, which was 12, and add those together, and you're going to get an answer of 15. Next week, Monday, we will be on Zoom, and we will do the second part of fundamental theorem of calculus. All right. So everyone have a wonderful day, and I will see you on Monday.